In this lesson, we're going to take a look at some compound events, which means probability dealing with more than one event. Up until this point, every situation we've looked at has been one event occurring. Now we're going to look at what the probability of two different events occurring might be and how you figure that out. So if you take a look at the first example, it says you throw two dice, one numbered 1 to 9, and the other letters A through H. Oops, and that's a little bit hard to see, but that's an H right there. What is the probability that you will roll a 2 and get an H? Okay, so what we're going to do is focus on the first event. So we have a dice numbered 1 through 9, and the question is, what's the probability that we get a 2? Well, if the dice is numbered 1 through 9, there's going to be one side that has a 2 on it. So one possibility of getting a 2 out of the 9 total sides that are on the dice. So the probability of getting the 2 is a 1 out of 9. So now let's take a look at the second event. So the other has letters A through H. Okay, so I'm actually going to list these letters: A, B, C, D, E, F, G, H. So on this dice, there's 1, 2, 3, 4, 5, 6, 7, 8 possibilities. Okay, and the probability that you would get an H. Okay, well, there's only one of the possibilities that's an H. So what we do for compound events is we take those two separate events and you multiply their probabilities. So the probability of the first event is 1 out of 9, and the probability of the second event is 1 out of 8. So if we multiply these two, and you multiply fractions straight across, you get 1 over 9 times 8 is 72. So the probability of that happening is 1 out of 72. And if we divide 1 by 72, you get 0.013889, which is the same as, if we move the decimal, it's the same as 1%. So the probability is 1 out of 72, or 1%. All right, let's take a look at another example. You are about to attack a dragon in a role-playing game. You will throw two dice, one numbered 1 to 9, and the other with letters A through G. What is the probability that you will roll a 2 and an H? So very similar situation, but it sounds like the second dice has changed. So again, we take one event at a time. So the first event, we have this dice numbered 1 through 9. So that means there's 9 total outcomes. And they're asking what the probability is that we get a 2. Well, one side on the dice is going to have a 2. So the probability of getting a 2 on that dice is 1 out of 9. Taking a look at the second event, we have a dice lettered A through G. So let's list them: A, B, C, D, E, F, G. So in this case, there's 1, 2, 3, 4, 5, 6, 7 possibilities. And an 8, what's the probability of getting an H? Well, there is no H on this dice. So there is a 0% chance that we would end up with an H. So the first probability is a 1 out of 9, and the second probability is 0 out of 7. So to find the probability of both happening, you would have to multiply. So if we multiply straight across, 1 times 0 is 0, and 9 times 7 is 63. So the chances of this happening are 0 out of 63, which is the same as 0, or in other words, 0%. So this cannot happen, since it would be impossible to roll an H on the dice. This one says your drawer contains 10 red socks and 9 blue socks. It's too dark to see which are which, but you grab 2 anyway. What is the probability that both socks are blue? So in this case, the chances of getting a blue sock, you want to think about this as one at a time. Okay, so the chances that the first sock you draw is going to be blue. Well, there are 9 possibilities of blue socks out of a total of 19 possibilities in the drawer. Now, if you pull out the blue one, if you pull out the blue one, for your next possibility, okay, your next event, Now, there are only 18 socks left in the drawer. So when you pull out the second sock, there's only 18 to draw from. And now if you pulled out a blue, now there are only 8 blue socks left in the drawer. So on your second draw, your chances of getting a blue sock are really only 8 out of 18. All right, so now we're going to do this the same way we did the other one. So the first probability is 9 out of 19. The second probability is 8 out of 18. And to find the answer, we're going to multiply these two. All right, but first, I would encourage you to simplify on this one because there is some simplifying that we can do. So if we look at, first of all, 8 and 18 can both be divided by 2, so that makes this 4 over 9. And then if we go diagonally, 9 and 9 can both be divided by 9, so this makes this 1 and 1. It makes the problem a lot simpler. So now if we multiply straight across, 1 times 4 is 4, and 19 times 1 is 19. So the probability of getting 2 blue socks would be 4 out of 19. And if we divide that, that's the same as 0.210526, which would be the same as 21%. So it's a 4 out of 19 chance, or approximately a 21% chance. All right, let's look at another example. All right, so a shuffled deck of cards is placed face down on the table. It contains 4 hearts, 6 diamonds, 2 clubs, and 3 spades. What is the probability that the top 2 cards are one of the clubs followed by one of the diamonds? Okay, so first of all, what is the chances that the top card is a club? Okay, well, if you look up here, there are 2 clubs in the deck. Out of, if we add up the totals, 4 plus 6 is 10, plus 2 is 12, plus 3 is 15. So the chances that the top card is a club would be 2 out of 15. Okay, so now we have to look at the second probability. Okay, so the second, it says followed by one of the diamonds. All right, well, in the deck, there are 6 diamonds. So there's 6 possibilities that the next one would be a diamond. And if we know that the top one is a club, there are no longer 15 total cards in the deck, but there's only 14 cards left with. So the probability of the second card as a diamond would be 6 out of now only the 14 cards that are left over. So now we're going to figure this out the same way we did the other ones. We're going to multiply these 2 probabilities. So again, the first probability is 2 out of 15. Second probability is 6 out of 14. And now we're going to multiply. But I would encourage you to simplify first. So 2/15 does not simplify. 6/14, you can divide them both by 2, and you get 3 out of 7. And now, actually, if you look diagonally, 3 and 15 are both divisible by 3. So this turns into a 1 and this turns into a 5. So now if we multiply straight across, we get 2 over 35. So the probability that it would be a club on top followed by a diamond would be 2 out of 35. And if you divide that, you get 0.057143, which is the same as 5%. So it's a 5% chance of that happening. All right, let's take a look at, so the next one says a bowl of fruit is on the table. It contains 5 apples, 6 oranges, and 2 bananas. Ethan and Adam come home from school and randomly grab 1 fruit each. What is the probability that Ethan grabs an orange and Adam grabs an apple? Okay, so we're going to start with the first probability. Ethan grabs an orange. Well, if you look at the top here, there were 6 oranges out of a total of 5 plus 6 is 11, plus 2 is 13. So there's 13 pieces of fruit in the bowl. So again, the chances that Ethan gets an orange would be 6 out of 13. So now if we look at the second probability, the probability that Adam gets an apple. Okay, Adam gets an apple. All right, well, the chances that now there are, let's see, 5 apples in the bowl. But since Ethan grabbed one of the pieces of fruit out, there's no longer 13 pieces left, but there are 12 pieces left. So the probability that Adam's going to get an apple would be 5 out of 12. So now the probability that both of these events happen, we need to multiply these two. But let's try to simplify first. So 6/13 does not simplify and 5/12 does not simplify. Diagonally though, 6 and 12 are both divisible by 6. So this turns into 1 and this turns into 2. Nothing else simplifies. So now if we multiply straight across, 1 times 5 is 5. 13 times 2 is 26. So the probability of this happening is 5 out of 26. And if you divide those, you get 0.192308, which is the same as 19%. So it's a 5 out of 26 chance or a 19% chance. All right, last problem. You accidentally dropped a coin from the top of 11 stairs. What is the probability that it will land above the second step and heads up? Okay, I'm actually going to draw a picture of this. So we have 11 stairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those are our 11 stairs. It says you accidentally drop a coin from the top of 11 stairs. What is the probability that will land above the second step and heads up? So the question is, what is the probability that it's going to land either so not on the first 2 steps, but it could land there. So that's 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 different possibilities of where it could land out of the 11 total possibilities that there are. Okay. And it says the probability that it lands heads up. So on a coin, there are 2 sides, 2 total sides, and one of those sides is heads. So again, the probability that it's going to land above the second step is 9 out of 11, and the probability that it's going to land on heads is 1 out of 2. So now we're going to multiply these 2 probabilities. But first, let's see if we can simplify. You can't simplify 9 over 11, and you can't simplify 1 over 2. Diagonally, you can't simplify 9 over 2, and you can't simplify 1 over 11, so nothing simplifies here. We multiply across, we get 9 on the top. 11 times 2 is 22. So the probability of this happening is 9 out of 22, which is the same as 0.409091. And if we move the decimal 2 places, that would round to 41%. So the probability of this happening is 9 out of 22, or 41% chance. So those are some examples of compound events.